Hello students. The next module is based on network functions. What are network functions? For understanding that, first we have to understand the concept of single port network and two port network. What is a single port network and a two port network? Any network can be drawn as a circuit which is having one set of input terminals. So let me call these input terminals as 1 dash, and the voltage that is given is plus minus V, and the current that is going inside is current I. So if you have any circuit or any network, you can draw or you can imagine that network as if it is having an entry point. That entry point is basically the single port network. For example, just as an example, suppose if you are talking of a transistor based circuit, then you can imagine that this is having an input like this. So if you want to connect any input voltage which you want to suppose we want to amplify it, then we have to connect it at this point. So this you can consider as the input port of the circuit. Similarly, in a two-port network, you may have an input as well as an output. For example, here itself you can see that you can have an output like this, 2 dash, the second port, and here you take the output and here you take the input. What is the need of studying circuits like this in single port and two port network is that if we are able to write very complex circuits, if we are able to draw very complex circuits in terms of two port network, then we can imagine how a set of complex circuit will work by joining many two-port networks in cascade or in parallel. So suppose there is a circuit which you want to make. You have the first part of the circuit which is a filter, the second part of a circuit which is basically an amplifier, and the third is basically, let's say, a power amplifier. So this three-stage circuit, you can do an analysis by doing this analysis of the filter, doing an analysis of an amplifier, doing an analysis of the power amplifier separately, and then join each of them together with the help of the ports. And suppose this goes through an antenna, so the antenna can be represented by a single port network. So here you are having a two-port network, here you are having a two-port network, and the final antenna is a single port network. So this whole circuitry can be analyzed if you draw it as a two-port network, each of the individual parts. And that is what most of the engineers do. Whenever they want to make a circuit, they make it in parts and then they try to join each other. So how to join and how to do these things and all we will understand in the fifth module. Okay. Right now what we are interested in is to find out two things about single port network, which are basically called as the network functions. So let me rub this one and I will say what is network functions. So we are interested in network functions. What are network functions? Network functions are they are the relation between current and voltages, or voltages and current, between voltage and current at different at different parts of the at different ports or parts of the network. There are basically two kinds of network functions, so I will write like this: network functions they are having two types. One is called as the driving point function, and the other one is called as the transfer function. What are these driving point function and transfer function? We will see very shortly. But before that, let me first complete what are the terminologies that we use in two-port network. So suppose if we are having a two-port network, it will have a voltage here, which is, since it is port 1 dash, I will write this as voltage V1, and I will show the current going inside, which is I1. Similarly, this terminal is 2 dash, and here the voltage I will write it as plus minus V2. And the normal sense says that here the output current should go in this direction, but here again I am going to draw the output current in this direction, which is I2. So remember, we always take the current I2 and I1 to be going inside. This we should not forget, because this is the general convention of naming the ports and the currents and voltages associated with it. So what is a single port network and what is a two port network, I have explained, and now we are going into the network functions, which are the driving point functions and transfer functions. So again, single port network is having only an input, there is no output. So single port networks are the end point of any complex circuit. Two port networks are networks which have an input port and an output port. The input port is 1 dash and the output port is 2 dash, and basically these come in the from the starting to the second last component, because the circuit will always end with a one port network, and in between you will have many two port networks. Okay, so let us first start with the definition of driving point function. Driving point functions are functions or relations between voltage and current in the same port. We are talking about the voltage and current relation, or the relation between current and voltages which belong to the same port. That means we will give an input voltage, or we will give a voltage here, which is called as, we all know, we call it as excitation, and we will measure also the things at the same port. So I will write the definition first. The definition is, so network functions are known as driving point functions if the excitation and the response are measured in the same port. So let us write the driving point function for one port network and two port network. So as you can see, the one port network has only one voltage and one current. So there are only two relations that can be there. One is called as the driving point impedance function. One is called as the driving point impedance function, and the second one is called as the, the second one is called as the driving point admittance function. Driving point admittance function. Okay, so what is driving point impedance function? It is basically, always we take it in terms of Laplace. So we know impedance is Z, it is given by V by current I. So here we are having ZS, and we write it as Vs and Vs by Is. So So what you should always remember is that here whenever we are writing V1, I1, it is all with respect to S. So let me write that. So this is V of S, I of S. This is V1 of S, I1 of S. Similarly, I2 of S, I2 of S, and V2 of S. Okay, and the driving point admittance function for single port will be basically Y of S, which is given by current divided by voltage at the port. So this is the driving point impedance function and the driving point admittance function. Why do we call it as a driving point? Because it is at the, it is the excitation and the responses at the same port. Whereas when we are coming to the two-port network, so two-port network, what is going to be the driving function? The driving function is going to be, see, this has to be taken for the whole. Okay, this has to be taken for the whole, and this also has to be taken for the whole. So let me use a different color for this. Okay, now for the case of two-port driving network, sorry, two-port network, there are two ports, isn't it? There is a port 1 and there is a port 2. So as we can see here, the ports are V1, sorry, 1 dash and 2 dash. So the input port will be V1 I1 and the output port will have voltages V2 I2. So what we can say is that the driving point impedance function will have, for the case of two port network, it will have two values. One is Z11 S, which is basically V1 of S by I1 of S, and Z22 of S, which is V2 of S divided by I2 of S. I2 of S. Okay. Whereas driving point function, admittance function will be Y11 of S, Y11 of S, which is basically I1 of S divided by V1 of S, and Y22 of S is going to be equal to I2 of S divided by V2 of S. And from this you can very clearly see that Y11 is going to be the inverse of Z11 and Y22 will be the inverse of Z22. Okay, so these are the driving point functions. Let us look at the transfer function. So I told there are two types of network functions. One is the driving point network function and the other one is transfer function. So what are the transfer function? Transfer function is when we are talking about the case voltage and current relation, okay, between one port to the other port. It is always between one port and the other port. So transfer functions again okay. Now since we are talking of other port, so we can have it only for a two port network. So we will say that it is only for two port network. It's not for one port network. It is only for two port networks. And for that we will have four different kinds of transfer function. Okay, but before that let me write the definition. So it defines the relation between voltages and current of two different ports. Okay, that means you apply the excitation at one port and you measure the response at another port. Okay, that is excitation is at one port and response is measured at another port. Okay, so two port are there are many port function, but we will be discussing only with two port networks. Okay, so let me write the four ones and write the equations for it. First is the voltage transfer function, which is G12 of S, which basically connects the voltage V2 with respect to V1 of S. That is, what is the voltage at port 2 when you apply voltage at V1. Similarly, we can have G21, which basically says that if you are applying a voltage at V2, okay, what is the voltage at V1? So that is the voltage transfer ratio. The second one is current transfer function. Now, before that, voltage transfer function basically tells us what is the voltage amplification in a way, or attenuation. Okay, so if V2 is more than V1, we will say that yes, amplification has taken place. If V2 is less than V1, we will say attenuation has taken place, attenuation of the voltage. Similarly, when you are going from port 2 to 1, what is the voltage transfer function? That is what is V1 by V2. Similarly, current transfer function is talking about the current amplification. Okay, it is between again 1 and 2, which is written as alpha. It is written in terms of alpha. So alpha 1 to S is the current at second port when you give a current at first port, and similarly alpha 21 S is talking about what will happen at the current amplification at first port when you give current I2 at the second port. And similarly, so voltage and current amplification has done. Then the third one is transfer impedance function. Transfer impedance, sorry, let me write the spelling correctly. Transfer impedance function, which is in terms of Z12 of S, which is V2 of S by I1 of S. So if you are having a current in the first port, what is the voltage at the second port? Based on that, you have the transfer impedance. Why is it called as impedance? We can see basically because it is voltage by current. But why is it called as transfer impedance? Because it is talking about what is the impedance during transfer. Okay, when it goes from port 1 to 2, what is the impedance function during that transfer? So similarly, we can have Z21 of S, which is basically what is the voltage by current. So again, it's impedance, so it is voltage by current. But voltage at 1 when you are having current at 2. So what is the transfer, from the other side when you see what is the transfer impedance function. The last one is the fourth one. It is basically called as the transfer admittance function. Transfer admittance function, where we are having admittance which is y. I'm going from port 1 to 2. What is the admittance at transfer from port 1 to 2? That we get by looking at what is the current at the second port when voltage V1 is applied, like this voltage at first port is applied. Similarly, Y21 of S, which is basically what is the current at first port when voltage is applied at the second port. Okay, so these are the transfer functions, and previously, as I said, driving point functions, and these are the values which we need to find for each and every network, whether it's a single port network or a two port network. We will see examples of this in the second video. Thank you.